Hi, International. I'm sorry I'm not there with you today. You can hear my voice that to take a day off and make sure that I'm fine. So, on your worksheet, follow along and fill it in as you watch this video. We have different rates of change that can be equivalent. So, one way of saying a rate of change is every time x increases by 1, y increases by 3. Or you could write that as delta y over delta x is 3 over 1. Change in y is 3, change in x is 1. Now, equivalent, you could say every time x increases by 2, y increases by 6, or a rate of change of 6 over 2. Now, that reduces to 3 over 1, so we know it's the same thing. Try to make another rate of change that's the same. So, for example, you might write every time x increases by 3, y increases by 9. Because if we write that as a fraction, that's an equivalent rate to the other rates that we had before. Okay, now let's look at this table. This is showing the rate of change that we just talked about. So when x goes up by 1, y goes up by 3. When x goes up by 2, y goes up by 6. From 5 to 11 is 6. Now, how could we fill in these other things? Well, here x is going to go up by 1. So y would have to go up by 3. So 5 plus 3 is 8. And if I think about that, now we're going up 3, up 3, up 3. So from 11, now this is going to go up 1. So this is going to have to go up another 3. And then take these points and plot them on the grid. So we can tell this is linear because those points are all on a line. The fancy way to say that is collinear, all on the same line. And then it says find 2 other points that would be on the line. Then we could think about, well, if I started with 5, 14 and just kind of kept going, if I went to 6, then I would have, adding 1 here, I have to add 3 here. So I'd have 6, 17. And 7, I'd have to have another 3, 20. And we can kind of see on the graph that that would kind of continue our pattern. We can tell this isn't proportional because if we went backwards, we'd have to go over 1 and down 3. And that would not go through 0, 0. So this wouldn't be proportional. But I could include that point on there as well, which is 0, negative 1. Right? If we took the table and went backwards, we would get to 0, negative 1. All right, on this page, I'm telling you that you've got a linear pattern, and you're going to complete the table. So remember, linear pattern means constant rate of change. So it seems like every time x goes up by 2, y goes up by 1 in this case. So here I see x goes up by 2, so y must also go up by 1 again. So there we go, 1. And then I've got x going up by 2, and yep, y goes up by 1. Now be careful on this next one, because now I've got x just going up by 1. So if x is only going to go up by 1, then y can't go up by a whole 1. Y can only go up by 1/2, or maybe 0.5, you might say. So let's make this a 2.5, right? So now we'll plot over here. And if we did it right, we should see that all the points are lining up on a line. And it does seem like they all line up on a line. So that's kind of a double check that my pattern really is linear. And then it says find the rate of change. So there's lots of ways that I can do that, right? I can tell right from the work that I did over on the table that my change in y is 1 every time my x changes by 2. Or I could do my y2 minus y1 over x2 minus x1. All right, so I can choose any x's and y's I want, so I'll just choose these. I'll choose this as x1, x2, y1, y2. So then I've got 0 minus negative 1 over 0 minus negative 2, and that also gives me 1/2. So either way, I'm getting a slope of 1/2. All right, let's look at one more together here. So it says use a linear pattern to complete the table. So this time it seems like x is going up by 2 and y is going down by 4. Okay, so let's be careful now. If x is going to go up by 1 this time, y can't go down by 4. It's got to go down by half as much. if I'm going to have the same rate of change. So I'm going to only subtract 2 this time. So that would get me to -1. And then from here to here, that's up by 2 again. So every time x goes up by 2, y goes down by 4. That was the pattern. So if y goes down by 4, then I've got -5. All right, let's plot those and make sure that we got. Yeah, that looks good. All those points line up in a line. So this next thing asks me, if the pattern were continued, what would be the y value when the x value is 6? Well, let's see. From 3 to 6 goes up 3. So how far would the y have to go up or down? Well, it's going to go down. And I can see from this row that when x went up by 1, y went down by 2. So if I'm going to go up by 3 on the x, then I'm going to have 3 times the change on y. So that's going to have to go down by 6. And that's going to give me a -11. To find the rate of change, you can do the same thing we did before, just a simple delta y over delta x. So you can see that we had, in one case, -4/2, which would give us a -2. And in another case, we had -2/1, which also gives us a -2. So either way, you should get a -2 slope. You can see that in the graph. And if we kind of even filled in some extra points here, we can see we go down 2/1, down 2/1, down 2/1. All right, this one is the same idea. So I want you to try that one on your own and then check your answers on the answer key. When you get to this page, take your paper and fold it along this dotted line so all you can see are the tables. What I want you to do is check, is this pattern linear or not for each one of these tables? And then go back and label any of them proportional if you think they're proportional. Unfold the paper and check your answers on the graphs. But don't use the graphs when you're doing it. That's your challenge. Once you finish this, you're going to open up the agenda, and you'll see the answer key will be linked here for you to check your guided notes and practice. And then you're going to work on this Desmos activity that we haven't gotten to earlier in the week. Your only homework is to complete that Desmos activity if you don't complete it in class. Please do turn in your homework that is due today, the proportional homework that you've been working on for the past 2 nights.